So basically, according to the pre-announced plan, what we want to do today is to first go over the merge requests, basically merge requests and what happened over the last week and what's hopefully going to happen over the few coming days. And then we will switch to the to Cardano SPO case overview by Dagen. So here is our merge requests. Let's go to what was merged. So I will go over them from the 1 week old, and we'll just say a few sentences regarding that. Okay, so that was already 2 weeks ago. Device owners can choose to pause onboarding and machine from command line. This was done by Avi, merged, and I believe this is merged into the onboarding script. So now the add static analysis to CI/CD pipeline. This is the stage finished. Yeah, static analysis stage finished by Ola. As a part of the CI/CD pipeline, which is itself kind of CI/CD failed on that. Then unit testing script. Right, what is it? Ola, do we have Ola? I don't see participants, so if anybody could say, do we have Ola or not? No, we don't.
He said he's training today, I think.
Yep, all right.
No.
So basically, I believe this was the first sort of unit testing, first merge into the unit testing stage of the CI/CD pipeline, and then Ola did a bunch of tests on the CI/CD pipeline. Now make DMers talk to Firecracker VM. So we have a merge. I believe this was merged by Dagim, and this is something that Santosh did. So Dagim, would you be able to just summarize what is that?
So this is the first version, the first attempt at getting the device management service to be able to manage Firecracker virtual machines.
And in terms of managing, this means
it can create an instance, kill it, supply the root FS, the kernel, every parameter that's necessary to start the Firecracker virtual machine.
Yes. All right. So this was 4 days ago. Now we have a merge request, which was requested by Dependra. Feature 12 starts database update and metric configuration. Again, Dagen, would you be able to just say a few words?
Okay. This was done by Dependra. It's for the stats database. So after implementing the, actually first standardizing the events that are going to trigger an update to the stats database. And also implementing the event listening server. This specific merge request is for updating the database schema, the exporters, and a new dashboard to see the stats of the platform.
Yes, and just connecting the next thing that Dependra is working is connecting this to the telemetry API and to sort of specifying this. Now non-intrusive measures. By the way, if you have any comments, please just jump in on your respective merge requests. Now, non-intrusive measures for any pre-existing Docker before creating a new one. To specify nomads NVIDIA container runtime backups. This was requested by Avi. And yeah, if I remember well, these are kind of few technical aspects that he was solving on the onboarding script, current onboarding script, which will have to be ported to the domain of device management system if it's not ported. Avi, would you like to just say a few words what it exactly does?
Yes. So actually, the thing was, there is one setting which is allowed underscore runtimes. Using that, we should be able to make Nomad see the NVIDIA container runtime when it is installed. But when I tried checking that, when I tried doing that, it didn't work. So that is why I had to separately specify this file, create this file. And when I'm doing it, I also need to ensure that when I'm onboarding, when I'm doing this change, I should make a backup of any existing JSON file. And when the user chooses to, when the onboarder chooses to uninstall the script, then it should be able to restore the original backup also.
So I think these were other kind of merge requests. Yeah, these are other merge requests, I think. But this is important for Santosh to take into account that all these functionalities have to be also implemented in the device management service. When we kind of depreciate the NuNet, I mean the onboarding script, these commits were done into the onboarding script. So yeah, we have to implement this on the device management service. And yep, so another one that I just mentioned is the configuration files created at NuNet onboarding should be used to read for debugging, troubleshooting. This one I think was formatting issue, right?
Yes. Actually, I could have done it using the existing Python JSON library, but I discussed with
okay.
PG. Yeah.
I remember we had also discussion during the daily.
Yeah.
All right.
I discussed with PG also, so he said that JQ, including JQ, would be helpful for testing different configurations.
Okay, so these are basically just an overview of merge requests, merge requests over the last week. Then we have a bunch of merge requests open. We can actually check whether we closed anything without merging, which was, not a lot, just some feature tests by Ola. In terms of open merge requests, we have, again, tests. Actually, we don't really have open merge requests. Now, we may go to the I think we will not. We may go to the open issues, but I think this is something that we discussed already during dailies, and also, we talked about this during dailies. So probably we won't, unless somebody thinks that I missed anything that was done and not logged here. Yes, did I miss anything which was not somehow written here? What happened during last week, which is not reflected in the mesh requests that are merged?
No, I don't think so. I think we also covered the ones from last week as well.
All right. So unless we have any questions, let's move to the next phase, which is Cardano SPO.
Let me start with background on where the decentralized SPO use case. So the decentralized SPO use case, the main goal is to be able to run the Cardano nodes. So these nodes are what keep the Cardano blockchain alive. So the node does block producing, approving transactions, and basically building the blockchain. So we noticed that most of the nodes are running on big clouds, AWS, and on big cloud company hardware. So we started attempting to build a way to have those nodes run in a decentralized manner. So one, it would help even decentralized Cardano even more, and it also helps us uh, achieve to build NuNet for specific that make them useful for specific community downloads on on the platform. We've been building several components for the last few months, where we have to build the pipeline in which just to define a term, an SPO is a stake pool operator. So stake pool operators are basically just as the name suggests, create a pool of Cardano wallets that are staking their um, uh, tokens, and uh, uh, they work as block producers. They approve the transactions since Cardano is proof of stake. So they approve transactions, and so when I say SPO, that's not what I want it to be. So stake pool operators. So the current thing we're going to build is uh, the functionality for the stake pool operators. So for the stake pool operators, the pipeline that we are going to be building within the coming couple of weeks is the way for SPOs to request for Cardano node instances within the NuNet platform, and creating those instances, allowing those SPOs to have remote access, shell access to the instance that has been deployed, so that they can do maintenance. Once this have been built, the other things we're going to have to do is basically study uh, how running Cardano nodes on user uh, uh, consumer computing devices uh, uh, is how advantageous it is, and how many rewards they are going to be able to earn by running on NuNet, so that we can calculate the compensation for running Cardano the instances on NuNet platform. So the current goal, the current thing that we're working on is the pipeline, and the way it's supposed to go is we've decided that we're going to use the device management service uh, uh, as the application that goes that handles everything at the user endpoint related to NuNet platform. So just the same as, let's say, as an example, if you've used Nomad for your work on NuNet, then you know that the one binary that Nomad ships, it can act both as a server and as a client, depending on how it's launched. So we're also taking the same thing for the device management service, and it can also serve the stake pool operators and also the device providers who are going to have the actual Cardano instances running on their devices. So the description of the pipeline would be basically we already have a variable that is set when onboarding a device, which is allow Cardano. So if a compute provider allows the deployment of Cardano nodes on their devices. Oh, by the way, that question is only asked when a device has a certain amount of resources. So there is a minimum requirement to launching Cardano. So if it's below that requirement, then that device is not suitable for Cardano, so they're not going to get asked that question. But if there is a device that's capable of running a Cardano, and also they set the amount of resources to make available to the NuNet platform above the minimum requirements set to Cardano's, then they would have the ability to give consent and have Cardano's deployed on their machines. Once they give consent, that variable would be set like Cardano,
And the first thing we're going to have to do is to include that variable within the DHT. So when a device introduces itself, when a peer introduces itself to the network, it should be able to indicate that that device or that peer uh, uh, allows further downloads to be deployed. So the second thing is, as mentioned earlier, the device management service is also going to be responsible for, it's going to be the application used by both the SPOs and the actual compute providers. So when an SPO wants to run Cardano instance within the NuNet platform, they would have an endpoint where they can request for that. So the request first, what the request first does is run a search on the DHT to see if there are any devices that allow Cardano to be deployed. So after the search has been done, there are definitely going to be multiple devices that allow that. So one thing that we haven't decided yet, but which can go either way, is for the device management service to select that device automatically, or for the stateful operator to select manually. We can start with um, uh, selecting those devices manually, since we don't know a lot about what kind of devices we're going to be having on the network too much. Uh, so the stateful operator would have a list of devices that they can choose from to deploy their instances. So after selecting a machine or a peer from the network, triggering the deployment process, what happens next is this request would directly pass on to the peer through the peer-to-peer network. The other peer that is going to have the header and supply it with a certain amount of information. So the uh, primary information is the public key of the uh, uh, requesting peer, that is the SPO's device. So once that information is supplied to it, and the uh, machine or the peer that is going to have the download running uh, has that information, it is going to be able to build. It's going to build the firecracker image specific to that user. So the public key, the importance of it is two things. So the first one is to be able to encrypt the file system uh, with uh, with a key that's known to the requesting user, the SPO. And the second use is there is going to be remote shell access to uh, to the remote device through the peer-to-peer network. That component is already implemented, but it needs to be it remains to be integrated. So in order to only allow the remote shell access, basically similar to SSH, um, before a user can use public authentication with SSH, they they will need to have their public keys uh, stored in the authorized keys file of the uh, SSH server, and the client that's going to connect to that server needs to have the private key that corresponds to that public key in order to make that connection. So that key is going to become important for the security of the virtual machine that's going to be created. So once the device management service on the machine that's going to be running the Cardano node finishes preparing the virtual machine, basically adding the remote shell access component, configuring it with the correct key, and launching the instance, it will send a notification back to the requesting machine or peer, and uh, it will be ready. So at this stage, there are two things we'll also have to decide. Basically, whether to give a generic Linux access to the SPOs so that they can configure their Cardano's by themselves. And the other one is to prepare ready-made images that would take specific configurations that can be set with variables that and supplied by the stateful operator during the request for deployment of Cardano's be supplied to the images that are going to be running on the other machine. So that is also going to be an ongoing process to decide and to see which one is going to be better. But we might start with having a generic repository. Also, one thing that Keros is currently working on is a Go module to automatically build firecracker images, because so far we've been building them manually, and we realized it's very easy to build them using Docker files, since all we need are root APIs file systems. So if we can describe those images using Docker files, which are very good at describing what an operating system can look like, then that's where we are going to take this stuff. So I think that covers the updates. If there are any questions, or Javier, did I miss something?
Okay, unless there are any sort of specific questions, what I would like to do is to basically go over that. Basically, because to go over this and to kind of build a diagram that hopefully will become a kind of yeah. We want to also to define all these things in terms of sequence diagram that will find its way to all the APIs that we want to like update based on this use case. So yeah, I would. What about if I go over this and kind of draw this diagram and ask what I miss, and then we could sort of discuss that. Does that work?
Yeah, sure. Yeah, that would be good.
So let me share the screen. Yeah, so I also encourage everybody to sort of participate if you see something that is relevant. All right, so what you mentioned, the first step that we have is basically machine compute provider. Pretty much on board the machine. And that either on the onboarding script. So in order to be eligible for the Cardano, now Dagim, can you remind me? Because so basically the way NuNet works is that we collect preferences of machine owners, not only the technical capabilities of machines, but also preferences. Do they want to run Cardano nodes? In the prototype, now we have the question, do they want to run Cardano relay node? So if I remember, so we had Cardano network, basically Cardano network consists of three layers. One is public relay node. No, how is it called? Passive, not public.
Yes, actually the main ones are the relay nodes and the block producer node, but a third one is an air gapped device that is not connected to the internet, that is going to be used for storing private keys.
So can you repeat? I mean, so I'm trying to understand. So basically Cardano network is, maybe I'm using the incorrect name, passive relay node, is it correct?
Yeah, there is the passive relay node, which is if you've used the wallet DRLS, then that is a passive relay node. It takes a copy of the blockchain to itself, and just becomes just passively observes all the transactions that are being approved, and
Right.
automatically
So
checks the integrity of the blockchain.
do we allow this to
Yeah.
run on NuNet now?
I don't see the use for it, but there are volunteers that would like to help the Cardano blockchain have integrity, then having passive nodes, as many passive nodes as possible is a good idea.
So if I could, I mean, we already have this implemented.
Yes.
So this one is, let me have a different color if I can find it. Oops. Yes.
So the other nodes.
Basically, this one, oops, why is it black? Yeah, so we already have this, and we just need to figure out what will be the like business process and reason to how to monetize this. But basically, technically, this is implemented. Now the other nodes are, and let's take it as a NuNet architecture. Basically, we combine another relay node.
Oh, the NuNet relay node is different.
Okay, NuNet relay node is a different.
Yeah, let me explain both of them.
Yeah, but NuNet relay node is a different stuff. We are now explaining the
I'm saying,
Cardano.
Yeah, the two nodes, yeah. The relay node and the block producer node.
And then block producer node, what we're doing, since they are a producer node, this is Cardano. That would be a very lousy picture, but sort of. So what we're doing, we are putting them into Firecracker containers, both of them, into one VM, right? In order to be deployed on NuNet.
Yes, yes.
And this is related to Cardano.
That is an issue, yeah, we faced with the communication between relay nodes and the block producer node.
The thing that we are solving is basically first, they contain private keys. They have to be
no.
Okay, sorry, they don't.
But the block producer node is still sensitive. That's why the encryption is necessary.
Yes, so this is why we encrypt this.
The virtual machine.
The VM, and also we allow SSH access.
Yes, that is also custom built. It's not actual SSH, but something to work with the IPv8 peer-to-peer network. So as a module, it was implemented a few months ago for the decentralized SPO. So
now, in terms of onboarding, so we already have in onboarding script, we have a question. Do you want to run this node? And basically, this was implemented a few months ago already, except that nobody was basically running them because it's still quite heavy and nobody pays for these things, which is in principle.
Also the variables,
yes.
Also the variables were set on for normal.
Okay.
Now we're going to change that to become on the DHT.
DHT. Okay. Then during onboarding, now what you said again, people can choose to run this guy. I mean the block producing node.
Yes. Yes. That one will be the monetizable. The passive node is to be preserved for
yeah. So with relation to, I mean, the broader picture of this, where is this pen? The broader picture of this is that whether it's onboarding script or DMS, so one of the functionality, we have to allow people to say what they want and what they do not want to run. Now, how do we exactly sort of do this? It's a kind of a question. Do we want specifically people to say, because what the DMS will check is what are the capabilities of not in terms of hardware. And if there are sort of capabilities to run Cardano node, which is pretty much a computational process, we may or may not ask users to give the preferences, because we may not want to ask everything. But yeah, let's keep it. So, but this question would be different. For example, if I'm computer provider, I would like to know which one I run. Do I run SPO or do I run passive node? So, do we have this kind of two questions now, or not?
Yes, we're going to need to separate those.
Okay, so that's separate.
That means if we're going to keep the running the passive nodes.
So basically, what we have then, we have metadata on the machine. Oh, that's kind of not a on the machine, which lists all those preferences together with with the hard ones, with RAM, CPU, etc., plus the preference to run something or not. So now,
hello, can you guys hear me?
Yes. Hello.
Hello. Oh, sorry. Audio got disconnected.
So suppose after that, and then we basically, SPO is a kind of a user. So here, compute provider simply provides the compute. Then SPOs are stake pool operators, which are basically support Cardano network as such. And then they will issue. So how will you said that we are going to get the request from SPOs through what? How do
using the device management service. So just the device management service should have the capability to serve those stake pool operators. So what we're going to have is a functionality for them to request for an instance to be deployed.
So basically, device management service. So SPOs will have to install DMS on their machines.
Yes, that's actually required so that they have shell access.
Okay, so basically they have to join the NuNet network themselves, and then through that they will issue a call, which I believe now is REST API, call to the DMS service to deploy the stake pools. Okay, and this call basically goes to DMS on the machine, which then accesses DHT on that machine because DMS, DMS, that's not correct. So it will access DHT on that same machine, right? Asking, do we have any free resources to run your stake pool? How big is the stake pool?
It varies from stake pools to stake pools, but I think we're going to have to see that in action.
Yeah, right, but more or less, plus minus, minimum, maximum. Anybody knows?
Yeah, not me.
All right, we'll have to check. Figure this out, and at this point, we'll have to onboard people with those machines. So we check the DHT for the machines which have those resources, and then we kind of there is some sort of. So who does the deployment? Suppose DMS gets the answer, yes, I know the machine 1, 2, 3 can run you. What happens next?
Yeah, let's assume there are two DMSs, one from the compute provider and one from the SPO.
Okay, so let's say I match with one compute provider. Again, DMS, right? So what happens next? This is on compute provider.
Once the actually most of the job is going to be done by the DMS with the compute provider.
This one.
So yeah, once the request is received, it has the key and the peer ID of the DMS, the SPO DMS that is doing the request.
Okay.
Yeah. Then the DMS at the compute provider side, it's going to start building a Firecracker image. So that's what Teros is doing now, a Go module to build Firecracker images out of Docker files. So this also solves the problem with registries for Firecracker images. So we're not going to need to have actual registries that are going to store the entire image, and that can be downloaded from somewhere. But what we're going to have are Docker files, which are basically going to be descriptions of those images. So the device management service on the compute provider side will pull that Docker file. We can store that anywhere, at least for now. We can make that fetchable from curl, or we can have a certain peer within the network that's going to keep this information.
Sorry, which information? I missed it.
Registry, basically. So what kind of Firecracker image to build? So it's going to be a Docker file for now to describe the Firecracker image, just the same as Docker files describe Docker images or OCI images. That standard can help us with Firecracker images as well.
Yeah, so but what I understood, we are keeping Docker images or OCI images, we're keeping in registry.
Yes, on the registry, we're keeping the Docker files or the descriptions, not the actual image.
And why not?
Well, one, that's going to be also a lot of work to pull, because the images are going to be very large, and it's easier to build them somewhere than store them.
So basically, you will pull Docker image description from the registry into this machine.
Yeah, also one of the influences was also doing the encryption and modifying the image before it gets deployed, since it has to be encrypted, and the remote shell access component modified with the peer ID of the requesting DMS. It's better to do that in one go while the image is being built, instead of having a generic image that is built, then pulling it by the DMS and opening it up, doing the modifications, and running it.
So you're building not only Firecracker but also Docker inside the provider for the whole Cardano node. And you think that it's more I mean, it's easier to build it in the machine rather than pull it from the registry.
Yes.
All right. It would probably will have to test it how it works, but yeah,
yes,
I mean, as a working solution. All right.
Yeah.
So
then while it's doing the build, at the end, it would also take care of the encryption and also adding the files, adding the keys for the remote shell access component.
So customization, basically user customization. Okay, and actually the registry for Docker files, do we have it? Do we have to build it?
Yes, but at least at the beginning, we can use simple file fetching. Like basically, we can use Nginx as a file server, and we can store them somewhere.
Okay, so from the platform perspective, now we have two kind of ways to deploy containers onto the platform. This one is to pull the pre-built containers from the Docker registry, which we have. Another one is to build registry, and so one is pre-built images, and another would be Docker files, and build them locally. Okay, so then when we build it, that's it. I mean, at the end of the day, we have basically the station where we have SPO, with DMS on one machine.
Yeah.
Then we have NuNet platform with a P2P network or IPv8, whatever we call it. Then we have a compute provider with okay, Cardano node running on it. No, actually not Cardano node, stake pool, sorry, which is kind of Cardano node anyway. And basically ability for those guys to access it via kind of a hack on SSH. I still don't understand how exactly, why do you call it? Pretty much shell access, right?
Yes, we're just calling it shell access because it's similar to terminal emulators, which basically create a fork of processes. So, for example, when you type ls on a terminal emulator, it basically forks the process ls, gets its output, and prints it on the terminal, right? It basically functions like that, but it sends the data through the IPv8 network.
Yes, because it's asynchronous.
So yes.
And what is going on here? Okay.
Like if we were going to use normal SSH, then we'd need to do port forwarding through a central machine with a public IP address, and that one was not favorable because it would be a centralized component in a decentralized network.
So, all right. So one thing that we yeah, maybe I will go to anybody from the team who has any comments, questions on all this stuff and relations to the parts that they're doing, components. So, yes, what did I want to ask further? Right, we had in the initial sort of design, we had the question: how do we solve data persistence?
Yes. So the two things that remain to be solved are the data persistence one and communication between relay nodes and block producer nodes. So since we didn't solve the communication between relay node and block producer node, we're deploying them on the same virtual machine. It's not a good approach. It's because Cardano has the relay node as a security barrier, so that the block producer node is not connected directly to the internet, but the block producer node would sit somewhere and only talk to the relay node, and the relay node becomes basically a jump server, as you could as an analogy. But we definitely going to have to solve that. But it's best to have something functional than work on these things.
Okay.
I think communication is not is getting difficult because of Cardano's the way they communicate. It's very hard to get to relay through a peer-to-peer network. It's an actual socket with a TCP network, so it requires a certain amount of aliveness to the network. So it has to be kept. The connection has to be kept. But with peer-to-peer, it basically goes and comes back, and it takes a different amount of time that it takes to reach for one message than it does the other, and the very nature of doing it through a peer-to-peer network is the problem. But we can have some other way to solve it, because yeah, we can also learn from Cardano's own peer-to-peer protocol, which is not released on the mainnet yet, but it's they're also developing their own peer-to-peer network, so it might help as a guide.
All right, so here we have a workaround for this milestone, which is slightly or not slightly, it kind of breaches Cardano protocol.
Yeah.
However, here we basically do not have a solution.
Yes. Not yet.
Not yet, and right now, when we will sort of boot this thing, we will have to require people which run stake pools to basically guarantee that the machines are available 24/7.
Yes. Yeah.
And if they crash, then the whole stake pool crashes.
Yes.
We don't have a solution to back up and to keep the data persistent when the machines in the network go up and down.
Yeah.
Anybody has ideas in general how to approach this? Well, the thing is that we will have to solve it not only for the Cardano SPO, but for basically for the whole platform, because this is something that we have to ensure that the platform is capable of. So if anybody has any ideas, both technical, organizational, how to go about it, so please either, we can discuss them now, or you could just ping us on the Slack or otherwise. So come up with we can brainstorm about it. And also at certain point, since we probably will not be able to do this now, which means the whole solution will be some sort of prototype in this sense, but we'll have to solve it, let's say, immediately after.
Yeah. By the way, just a mention here, just as we discussed a couple of the technical discussions before, 2 weeks before, I think. Since so these kinds of problems, especially the data persistence one, they can be, there is an opportunity to solve them when we detach from sandboxes that are like Docker and Firecracker and orchestrators like Nomad, because if we're not running those applications in the traditional way they're supposed to be run, and if we do some dissecting and basically run them in an extremely customized manner, then there is an opportunity. So when you think of ideas, it shouldn't be restricted to the way that NuNet is currently functioning. Because so for example, if we have an application running inside a container, then solving the data persistence problem becomes about pulling the data out of Docker, storing it somewhere, then letting the application know somehow that the data needs to be copied or be transferred somewhere else. Also, the other thing we're going to face is, let's say one process cannot be shut down, similar to the Cardano nodes, right? So let's say we have two machines, and one is let's actually say we have three machines, A, B, and C, and A is running an actual Cardano node, but it's keeping its data on machine B, which is guaranteed to have 24/7 availability, but we're using it for storage because of its availability. So if machine A is not reliable and if it goes offline, we should be able to have a way to reinstantiate the process that was on A on machine C, and keeping the states as it was running, but then using the data from machine B. So in order to do things like this, we're going to have to go out of the current implementation. So any idea is going to be welcome. It's not going to be too crazy for the future.
Yes. So then we will postpone this design. Yes, please go.
Yeah, so for this case, I was thinking if there is some activation mechanism for A, B, and C, and while A is running, it is only active on A and deactive on B and C. So once A goes offline, so B and C could automatically activate B either of B or C. So could there be something like that?
Yes, but we're going to have to build those things. So let's say let's say think of already existing distributed operating systems.
Yes.
The way they keep state is by continuously communicating what each machine is currently computing. So we're going to have to move to an implementation like that, a platform like that at some point in the future, because it's also going to be necessary for the GPU use case as well.
Yeah.
Because
So
machine
so
learning.
we need some kind of listening mechanism, I think.
Exactly.
Yeah.
Also, for example, with the GPU use case,
Yes, yes.
machine learning machine learning trainings usually take a very long time, and
Yes.
you're going to want to distribute the job to as many machines as possible. And in order
Yes.
to do that, in the platform, there should be a way, something okay for
There
similar
should
to
be a
OpenMP
checkpoint.
or some. Yes. So
If
let's say
a machine learning job has run for 5 hours, so
yeah.
if it is not going to be available beyond 5 hours, then that based on the checkpoint, it should move on to machine B.
Yes.
Something.
So what you have with other platforms, especially with machine learning, is you have software like OpenMP or those other implementations where you do message passing at a very rapid frequency to let uh, other machines know where you are and where they are, just basically updating where everyone is.
Thanks, Dagim. Thanks.
Safi, I see you have your hand up.
Yeah, so regarding this case, there's a blockchain called the Internet Computer, and the way that it works, it's each application maintains its state, right? Like Avi was saying, but that state is universally accessible. So any other application can actually read, and depending on whether there's the application allows write access, they can read and write into other application states. So there's a global state that's shared amongst all applications that are built on the internet computer. So that's definitely one way we could do that if we can figure out a way to share the state. It's pretty much the same thing as we said.
Yeah, well, how do they do this? It's
So
Definity, right? Internet computer is Definity.
yes,
So how do they do
definitely.
this?
So they compile everything down using WebAssembly, and that state is maintained within the application. So each application has a sort of how do you say it? So there's memory allocation, right? So that memory allocation is where the state lives, and that memory it's on the block of the blockchain, right? So I'll have to look at the exact technical specification. From what I remember, the block has the state, and anyone can read into that block. So even if the application goes offline, which wouldn't happen in that case because it would be living on that block itself. So, but it would if we would take the case if it goes offline, anyone else can read into that state.
Right. So first of all, they have their own blockchain in order to implement that.
Yes.
Second, my question would be, because it's usually not computational in this case expensive, but communication-wise expensive, because you
Right.
have to put all the state and then how frequent the snapshots are. Now the blockchain, is it global? Do you keep all the states of all machines in the blockchain? And how do you manage it computationally? I mean, my questions are basically for this kind of, which may be a way to go about it, but my questions with this kind of solution is pretty much computer science theoretical. It's just not possible to keep global state of all machines in one place.
Right.
So I would be very interested to see how exactly this is solved. But yeah, I mean, in terms of the, at least the kind of conceptual architecture of what NuNet tries to achieve is actually to achieve the functionality of data persistent and state persistent, but this shouldn't be global. It should be local in terms of with respect to computing process.
Right.
Which is sort of distributed caching or something into that sort of direction, which may or may not be achieved here. In Definity, another option would be to think of, let's say, Cardano Hydra nodes. I'm just brainstorming. It may or may not make sense here. But right, I think it's good for us to look at all those solutions. That it's not that we are kind of alone in the space thinking about these things. To look at solutions that are present and to try to see what can we use, what we can kind of partner with, and what we can come up with.
Yes.
Yep. So Safi, if you could have kind of put some. We have an epic about that. We don't have, I think, issues, but we have an epic. So what we can do, we can sort of collect all this information in one issue and sort of put together so that when we reach the place where we will be able to attend to this, we
Right.
could have a list of resources.
Sure.
Okay, thanks. So from my perspective, just a question, Dagim. Actually, it's not just a question, but when do you think this phase will be reached?
Let's see. We're going to have to go as fast as possible on this. The Go module for building images is almost done. So what remains is the encryption and the networking. So by next week, I think we'll have the final work for the problem with the NuNet adapter and the device management service. So even if the current method keeps being unwieldy, going to move to an easier approach that is not desirable but guaranteed to work. So let me also there's going to be the endpoints for the requests and the deployment, which is also going to be built between Tedros, Santosh, and myself. So I think by the end of 2 weeks, I think we can have something that we can have enough progress, but hopefully we'll finish, but 2 weeks might be very small.
So basically this, okay. So the 2 weeks is kind of aggressive.
It's aggressive.
Aggressive, let's say most positive outcome, where
Yes.
we will be able to go to SPOs and say, okay, look, this is a test net, this is a test solution, please try it out. And then we would be able to make partners with SPOs concretely. All right. So anybody has more comments?
By the way, if the SPOs are creative enough, I think that they're going to be able to do their own port forwarding with their own machines to have relay nodes and block producer nodes deployed separately. So let's say they can request for 2 machines to have Cardano nodes deployed, and since we're starting with having the SPOs configure their own instances, they can basically figure it out. having starting a forwarding session from their virtual machine instance to their own public to their own machines with public IP
Yeah,
addresses.
and basically for pretty much that reason, we want to get SPOs on board. I mean, SPOs is not in general; it's the ones which with whom we will be partnering as soon as possible, because they may solve certain things that we are struggling with,
Yeah.
or at least suggest certain things.
And if it's their own centralized component, then it's going to be fine. It's not going to affect us.
Okay. So yeah, anybody else final comments, questions, suggestions?
Actually, I wanted to clarify one thing. When we are creating the Docker files, so are we including the apt upgrade command when building?
I think so.
Okay.
I think it's really actually very important and necessary. I always do it when
Yeah,
I
so it
write
will
Docker file.
yes. So that container will always include the latest security patches actually. So that's why I was asking.
Yeah, it's very important.
Thank you.
Yeah, but we will have to, even if we'll have to download a bunch of stuff anyway. So yeah, this will have to be tested for sure.
Yeah. Also, by the way, to keep the building minimal, since you're utilizing Docker for building those Firehacker images, the base image that is going to be started from, that can be managed by us. So let's say instead of saying from Ubuntu 20.04, we can say from Cardano 0.1 for NuNet. So we can take care of a few things that are going to be very common, such as upgrading and everything. So when the DMS from the compute provider side pulls the base image, then they can pull in images with a lot of stuff taken care of. So that there is room for us to lower the amount of build that has to be done from the compute provider side.
So the Cardano images are based on which? Can I know which distribution?
So with Cardano, they normally prepare one with NixOS, but they also have instructions for Ubuntu. So we're going to go with those two because the SPOs would be most familiar with those.
Okay, thank you.
All right. So I guess we are at the kind of 10 minutes over. So thanks a lot, everybody.